Hi students, I want to show you how this radioactive dating game works and show you some hints about how you can figure out some of the items that can't be aged with either uranium or carbon. So remember, carbon radio dating can only be used on things that were once living, that had carbon in them. All right, and so that would be things like skulls. This is a wood chalice, a drinking glass from maybe the days of the Renaissance. This is a skull. So these are all things, the house might be built with things that were once living. So we might be able to detect carbon. So let's see what we can detect carbon with. We're going to look here, 100%, it's still living. This is not alive, but it has 98.2% carbon. This is 100% because it's living. The house, 99.1%, so it was just recently living. And then we have a dead tree. Excuse me. We can actually, if we took this dead tree, we have this pointer here, and we can actually move this back until we get to the 97.4 that it shows here. And you would move that back until you're around as good as you can get, right? And it might not land exactly, but this case it did. So it says the time, it's 219 years long. It's been dead for 219 years. So you put 219 is, and you check, and woo, you were right. I'm going to reset this. So now what happens when you go deeper? We have carbon here, we have carbon here, we have carbon on this bone. So you can age those. We have carbon here just a little bit. But look at this probe, this graph only takes us down to 10.9%. So what can you do? Well, one thing that I did was I made this spreadsheet, and basically what I did was I said, okay, a number of half-life, one half-life means that 5,730 years have passed. How much C14 is remaining? 0.5 or 50%, all right? And I just put a formula in. I said, calculate for me, and here it is. I just said, this equals this cut in half, right? And so I just did a quick calculation here. So what I'm trying to get to is 0.8, right? So I know 0.8, well, we're trying to get to 0.8%, right? Remember that these are decimals, so that's 50%, 25%, 12.5%, and here's 6%. So I know somewhere that 8% or 0.8%, oh, we're trying to get to 0.8%, so I want to come down here. I know this is 3%, 3.1%, this is 1.5%. And so here's, now we get down here to 366. Now carbon isn't supposed to, carbon 14 doesn't work for really past, we learned that it doesn't work past 60,000 years. So what can we do? Well, we can come back here, and I want to show you something. There's this custom button, and when you click on this custom button and you have objects, okay, you have to click custom and objects. Look at what you'll find. You'll find that there's this drop down menu of 100,000 years, 1 million years, 10 million years, or 100 million years. So we need to go a little deeper than the 60,000 years. So I'm going to use this probe, and I'm going to see, I'm going to click on that, and I'm going to see if I get anything. And look at, I do. I'm going to use this custom probe. I don't know what it is, but it's a custom probe that can detect 100,000. Its half-life is 100,000 years. So I have So now I knew I have a new graph, which shows that one half-life is 100,000 years. And it says, my probe says I have 75.8% of this isotope. It's a radioisotope. It's different from carbon-14. It's different from uranium-238, but it's going to work for us. So 75%, I'm going to start moving my graph back this way. And I get to 75.8. It's somewhere up here, okay? And I'll let you play with that, but you're going to put the estimate here. And remember that if you don't get the exact number, so we got 75.8 here, and if I move it just a tad this way, I get to 76. So this is 39,419 years, which radiocarbon should date, but there was not carbon left. And then this is 40,000, so somewhere in between that number. So I'm just going to estimate maybe 39,000. All right, and put that in. And it was right. And I can click here and I can clear it actually if I don't get it right the first time. So I wanted you to know that there's this custom where you can try, if you get 0% on the uranium-238 probe or the carbon probe, try the custom, all right, until you get a decent percentage where you can use the graph of that custom radioisotope. I want to show you something with uranium. Remember, uranium can only estimate the age of rock, lava, what used to be lava flow, cooled rock. So it can estimate the age of this rock because this is cooled lava, but watch when I take it to a fossil. This is not a fish, meaning it's not alive anymore, and it's fossilized, so that means any living component has been exchanged with minerals. And look what it says. It says 0%. Well, that's because fossils are not cannot be aged with uranium. Uranium can only be aged with molten lava that has cooled, and fossils are not molten lava that has been cooled. So you're going to have to try one of those custom probes, and you're going to have to estimate. So first, figure out how old this rock is, right? And you're going to use the uranium-238, and you'll get, so uranium-238, I get that there's 97.9% of the uranium-238, and I'm going to have to move that this way, okay? So now you sort of have an idea of how old this layer is, but remember, based on what we learned about layers of sediment, is that this can be 100, 1,000, multiple thousands of years of a layer, right? It's not just 1 year. It's not going to be necessarily the same year as when this molten lava cooled, obviously. So I come over here, I try the uranium. It's not going to work here. So you might have to figure out which custom probe is going to work. And remember, you have to have press custom, and you have to hit object, not air. And then you'll get this little drop down, and you can see if you get something when you try this probe, 100,000. And let's see, I'm going to move it. Sometimes if you move it away and bring it back, okay, I'm still getting 0. So obviously this object is older. So I'm going to try 1 million, and let's see if that works. All right. And I'm still not getting anything. So I might have to try 10 million and see if I get anything in that radioisotope. And then I try 100 million, which makes better sense because this is in the bill. This is when we measured this, this was in the 100 millions too. All right, students, so I wanted you to know that there are these custom probes. You hit custom, you hit object. So if carbon-14 doesn't work and uranium-238 doesn't work, you do have some options with these custom probes to figure out how old these items are. And remember that you should know that the deeper the fossil or the deeper the rock, then the older it is. And when you do figure out, so let's say you come to this object, you do have to write out the number. You can't just put 1.4 billion years. You actually have to write the whole number. So you have to know how to write. So if we come here and it says custom 100 million years, and I've got this graph and it says 11.7. So I'm going to see if I can actually get down to 11.7. I might not be able to. I did. I can. Look at that. So now I see that it's 309.17 million years. I can't write this number. I actually have to write out 309,170,000. I have to write that number out. So it's going to look like this. And this program lets you pretty much, you know, it's estimating. So it's going to let you round. But I'm going to check my estimate and it worked. Okay, so you have to write out the whole number. So I hope this little tutorial helped you. I also want to let you know that I do have this, I will post this if this helps at all, this idea about half-lives, how many years have passed. But good luck tomorrow. I'm sure you'll do a great job. Remember, if you need to try again, you just hit reset. But the goal is to get all of them green, all of them filled out, and then take a screenshot for me and put it in your document, okay? To show me that you were successful with everything. All right, and feel free to collaborate with people. I don't want people doing the work for you, but you know, it doesn't hurt to get ideas from your friends. All right, good luck. Don't forget at the very end, I want you to screenshot all of the dates on all of the objects to show me you've done it, and screenshot that, copy and paste it into your Word doc that you're going to submit to me. All right, have a great Wednesday. I'll see you on Friday.